Welcome to the Department of Electronics and Communication Engineering, SSM College of Engineering. The Department of Electronics and Communication was established in the year 1998 with an intake of 60 candidates. The intake was increased to 120 in the year 2010. The department is equipped with state-of-the-art laboratories and ICT-enabled classrooms. Tech in Electronics and Communication Engineering was introduced in the year 2018 with an intake capacity of 18. The department is equipped with high-tech labs. The department was accredited NBA Grade A in the year 2007. Students can opt for on- and off-campus placements with reputed companies like Semiconductors, Alstom Corporate, Bart Heavy Electricals, Havels, Crompton Greaves, Neelix Cables, HBM Power Systems, Exide Industries, Siemens, BSNL, Sony Ericsson, etc. With sufficient knowledge of computers and coding, electronics and communication engineers can find jobs as assistant software engineers, junior software engineers, programmers, net engineers, quality analysts, and similar positions. Students use these labs for working on different projects. Our many projects have won national recognition. The department is equipped with 9 state-of-art labs like Analog Electronics Lab, Digital Electronics Lab, Microprocessor and Microcontroller Lab, PCB Lab, Communication System Lab, OFC and Microwave Lab, CAD Lab, Network Analysis Lab, Antenna Lab. The department has produced highly reputed alumni like Mr. Naveed Trambu, IRS, working as Deputy Commissioner Income Tax, New Delhi, Ms. Bisma Qazi who is an IPS officer working as additional DCP, Rohini District Delhi, Shakir Hassan, KPS working as Deputy Superintendent of Police and many more working in both national and international organizations.
We are the students of final year Electronics and Communication from SSM College of Engineering. We 5 students, Nazima, Mehmood, Mehwish, Tarun and Prerna, have equally contributed towards this project and came up with an idea of COVID-19 frugal ventilator. As we all know, the entire world has been battling a serious pandemic from almost a year now. The COVID-19 pandemic was at peak when we were about to start work on our project. This pandemic tested the whole world by all means and brought forth extreme shortage of resources. So we wanted to work on something which could somehow help the society, and thus we came up with an idea of designing a prototype for the ventilator. As it could somehow help in saving life, we named it Hayat, meaning life.
Now coming to our project, COVID-19 Frugal Ventilator Hayat. As we all can see the whole circuitry, Here we are using an Arduino Nano. It is the heart of our project which controls the whole setup. Alongside the Arduino Nano, we are using a buck converter which is simply used to step down the supply voltage so as to protect the Arduino from damage. As also we are using here a Bluetooth module which is serially connected to our Arduino. Now the question arises, how do we give input to the Arduino through this Bluetooth module? For this we are using here an Android app. Also we are using here a DC motor that is along with an encoder to get a higher precision. Here we are also using an L298 driver which is basically used to amplify the signal coming from the Arduino in order to provide the sufficient voltage for DC motor to run.
In this project Hayat, we are using an ambu bag which is used to generate pressure difference. This ambu bag is pushed by an 3D printed actuator. You can see here is a 3D printed actuator that comprises of encoder, DC motor and linear gliders. This actuator, we can move this with the help of microcontroller according to the settings required by the patient. When actuator is moved, encoder keeps track of position using Hall effect sensor and varies actuator position. Also, encoder controls the speed as well. We also here in this project we also use optical end stop which detects the presence of an object. It works whenever light is disrupted. But at the same time, when we are moving the position of actuator, here we have also measure pressure at the same time. So we use modified BMP 180 which provides accurate pressure readings in real time. This real-time data enables microcontroller to keep track of pressure that is being exerted on patient's lungs. Microcontroller also adjusts volume delivery as per pressure levels and settings that reduces risk of barotrauma. Now the most important feature of our whole project Hayat is PEEP, positive and expiratory pressure. So we use a servo motor. You can here see this is a PEEP valve using servo motor. This gives us a precise value of pressure. And also in this project we are using an Android app. You can see here is the Android app which we are using in this project, this Android app sets each and every setting of ventilator using Bluetooth module. We give the input in this Android app to the microcontroller using Bluetooth module. Here is in the circuitry we also use Bluetooth module. Also in this tidal volume we can measure the tidal volume. Here you can see we can set the tidal volume 495 and how the actuator moves by setting this tidal volume. By setting the value of tidal volume you can see how actuator moves, and if we raise the tidal volume you can see how the speed of actuator gets faster. This is how this system whole works. And also we can measure respiratory rate, FiO2, fraction of oxygen. Respiratory rate we can here can get 15 breaths. We can give 15 breaths per minute to the patient also, and we are giving 5 cm H2O, and we are giving 20 FiO2, fraction of oxygen, to the patient, and we are giving inspiratory expiratory ratio 2, and also we are setting the inspiratory pressure, that is we set here 40. This is how the whole setup is controlled and how this whole system works. Thank you.
प्रैक्टिस कर रहे हैं. हाँ.